Just try to imagine, for a second, standing at the foot of a building that was constructed 4,500 years ago. It's not just a building, it's a man-made mountain of stone, so huge and so precise it still kind of blows your mind. We are, of course, talking about the Pyramids of Giza, and today we're going to dig into the incredible engineering genius that made them possible.
So let's zoom in on the big one, the Great Pyramid of Khufu. You have to understand, this is so much more than just a tomb for a pharaoh. It's a statement of power, it's a masterclass in precision engineering, and honestly, it's a testament to some truly mind-boggling human ingenuity. I mean, there's a reason it's the last of the 7 wonders of the ancient world still standing.
To really get your head around this, we've got to look at the numbers, because when you do, you start to see why building this thing seems like an almost impossible feat, even with all the technology we have today.
Okay, first up, the building blocks. The pyramid is made out of roughly 2.5 million individual limestone blocks. Just let that number sink in. 2.5 million.
And we're not talking about bricks here. Each one of those blocks weighed, on average, 2.5 tons. That's about the same weight as a modern SUV. 2.5 million SUVs, basically.
And they stacked all of that stone up to an original height of 481 feet. That single fact made the Great Pyramid the tallest man-made structure on the entire planet for almost 4,000 years. A record that stood for nearly 4 millennia. It's just unbelievable.
But here's where it gets really crazy, the precision. The sides are aligned to true north, south, east, and west with an accuracy that is just stunning. And remember, they did all this without a compass. To give you some perspective, modern engineers with all our lasers and computers would have a hard time placing 20-ton stones with that kind of accuracy today.
Which, of course, brings us to the ultimate question. The one that has fascinated everybody for centuries. How in the world did they pull this off?
Well, any investigation has to start with the most basic thing, the stone itself. Before you can build a mountain, you've got to move one. And the logistics behind just getting the materials, that's a whole wonder in and of itself. What we see here is this massive kingdom-wide supply chain. Now, lucky for them, the bulk of the pyramid, the core limestone, was quarried right there on site. Super convenient. But that shiny, white limestone for the smooth outer casing, that had to be brought over from Tura, across the Nile. And then you have the really heavy stuff, these massive granite beams for the chambers inside, some weighing up to 75 tons. Those were floated all the way from Aswan, almost 1,000 kilometers away. And you can see that connection right here. On the left, you see the enormous scale of the Giza quarries where this all started, and on the right, that's a close-up, a microscopic view of the stone itself, packed with these tiny little fossils. It's just amazing to think that every single one of those millions of blocks has a story that began right in these pits.
Okay, so they had the stone, they got it to the site, but that brings us to the central problem, the big one everyone argues about. How do you lift millions of tons of rock piece by piece, almost 500 feet into the sky, using just ancient tech?
For decades, the go-to answer has just been ramps. And yeah, that makes sense on the surface, but it's not nearly that simple. See, a lot of the traditional ideas for ramps just don't work. A single long straight ramp, for example, would have needed to be over a mile long. Other designs were so huge they would have used up more stone and labor than the pyramid itself, which, kind of defeats the purpose.
So, if those old theories are shaky, what's a better idea? This is where modern engineers have come in with some new solutions that are not only workable, but are actually incredibly clever and efficient. One of the most convincing ideas, from an engineer named Stephen Briccieri Colombi, is this hybrid system. What you do is combine a huge, straight main ramp for all the initial heavy lifting, and then you add a more efficient spiral ramp that wraps around the outside for the upper parts. It's just a really elegant solution, using the right tool for the right job.
This main ramp is the real workhorse. The idea is that it was super wide and straight, and it ran directly into the pyramid's core. Now, why straight? Well, because you simply cannot drag a 75-ton slab of granite around a sharp corner. This ramp was the heavy-duty highway built for one purpose, to get those massive beams for the king's chamber up to where they needed to be.
But what about the millions of smaller blocks? That's where the spiral ramp takes over. And this is the truly genius part, figuring out how to get around the corners. This little model shows a simple but brilliant pivot system. Just by using wooden poles and ropes, stuff the Egyptians had plenty of, they could swing the sleds around those 90-degree turns without everything getting jammed up.
And for the grand finale, getting that final capstone, the pyramidion, right on top. For this last step, you don't even need the ramp anymore.
you could use an even simpler piece of tech, a shear leg crane. It's basically just two big wooden poles in an A-frame mounted on a platform. With something like this, they could have easily hoisted that final, crucial piece into place.
So what's the bottom line here? What makes this whole system so believable? It's the efficiency. The total amount of material needed for this entire combined ramp setup was only about 6% of the pyramid's total volume. That's the key. That's what makes this a practical, economically feasible solution, not just a fantasy.
Now that engineering solution is a really powerful and convincing theory. But it's so important to remember that it is still a theory. The debate is very much alive, so it helps to understand what we know for sure and where the arguments are still happening.
So, for example, the model we just looked at uses an external ramp that would have been taken down afterward. But another major theory suggests they built an internal spiral ramp right inside the body of the pyramid itself. And the big appeal of that idea is that it wouldn't have left any trace, which might explain why we haven't found a smoking gun for a giant external ramp system.
But while the experts debate different kinds of ramps, there's one popular idea they completely shut down: the theory that the pyramids were poured from some kind of ancient concrete. Geologists Dietrich and Rosemary Clem, who've studied these stones for decades, put it pretty bluntly. They say it should be clearly emphasized that such theories are nonsense. The evidence is overwhelming. The blocks were cut from quarries.
So, in the end, there probably wasn't some single lost secret or, alien technology. The real marvel, the true magic, was something much more human. It was an absolutely incredible feat of project management, incredibly sophisticated planning, and the organized, raw power of thousands of people all working towards one single monumental goal.
And that kind of leaves us with one last question to think about. What is the real wonder here? Is it the specific design of the ramp they might have used, or is it something bigger? Is it the sheer breathtaking ambition of a civilization to decide to build something so perfect and so massive that it would quite literally last forever?